The periodic table. You will notice on the periodic table that there are a bunch of boxes. In each box, there are symbols. These symbols represent elements. If an element has one letter to it, that letter will always be capitalized. Your example would be hydrogen, capital H. Sulfur is capital S, carbon is capital C. If it has two letters with it, the first letter will always be capitalized, and the second letter will always be lowercase. Your example there is aluminum. Notice the capital A, lowercase l, platinum, the capital P, lowercase t, and then cadmium. The origins of some of the symbols are not obvious. They come from Latin derivations. So gold, for example, you would think maybe it's like a G or a GO, but no, it's not. It's AU. It comes from the word auris. Lead is another weird one. Probably the weirdest one on there to me is antimony, and that's number 51, and that symbol is SB for antimony. Two very important vocab words that we'll use a bunch are column and group. Group and period. Group are the columns. So every column is a group. If you count the columns, you will notice there are 18. Therefore, there are 18 groups on the periodic table. Each group is arranged very carefully, and we will see that elements in the same group or the same column share similar chemical and physical properties. Okay, if you just look at the first group, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, all of those, now hydrogen we'll learn is weird, but these guys all are very, very, very reactive in water, explosive in water. That's a chemical property they share. So when we say, I will not use the word column, I will use group. You can also call it families, but group is used more often. So we will use groups. The rows on the periodic table refer to the periods. So period is the word we will use for the rows. You can count them as well. 1, 2, 3, 4, 5, 6, 7. There are 7 periods on the periodic table. You might be asking, well, what about these two down here? These two actually get inserted here, but they're called rare earth metals. They behave a little differently, so we separate them for other reasons that we'll see in chapter 4. But there are only 7 periods. They belong up in that gap there. So we have groups and we have periods. A lot of different information in the box. Every periodic table has different information. I've seen some with the box loaded with things. All kinds of different information. You can have melting point numbers, boiling point numbers. You could have what's called electron configurations. You could have their orbital shells. There's a lot. Densities. This is pretty basic. This is one that you'll see in the classroom. It tells you the atomic number, which tells us the number of protons. We'll learn that in chapter 3. That's the top number. It'll show you the symbol, which again can be 1 or 2 letters, and it can give you the atomic mass, which will be the decimal number. We will see that for atomic masses, in this class we will always round to 2 decimal places, to the 100th place. So when we're using hydrogen's atomic mass, we will round this to 1.01, because of course the 8 rounds the 0 up. Different types of elements. We have metals, we have nonmetals, and we have metalloids. Your metals are on the left side of the table. Now you might be asking yourself, well, what is considered the left side? We have something called the staircase. Something like that. You'll see it in the classroom. This has a red demarcation, this staircase. You can picture the staircase, someone walking up. That's why we call it the staircase. The metals are on the left side. So anything to the left of that are metals. You can see that most of the periodic table are metals. Hydrogen is an exception. Hydrogen is a nonmetal. It just fits in group 1 better because of what's called its valence electrons, but that's for another day. So metals are on the left side. What are the properties of metals? They conduct electricity, right? You don't run outside with a metal rod in a lightning storm because it conducts electricity, it conducts heat. Metals are shiny. Think of gold or silver. Vocab word, they're malleable, meaning they can be molded. They're ductile. They can be stretched into wire. Think of copper wiring. It can be stretched into wire, or it can be hammered very thin. Think of aluminum foil. Or big sheets of metal that you might see at Home Depot or Lowe's. Now, they are general properties. It will vary according to the metal you have, but for the most part, they are pretty good properties of metals. Nonmetals will be on the right side of the periodic table. If you know the properties for metals, then the properties for nonmetals should be pretty easy because it's just opposite. They do not conduct heat and electricity. They're not shiny, malleable, or ductile. Most nonmetals are gases. So let's look at the periodic table to see the right-hand side. Again, we have our staircase there. Your nonmetals are over here. Most are gases. These, the ones that I'm drawing on, are your gases. So right side nonmetals, left side metals. And then we have the metalloids. These are your in-betweeners. They are touching the stairs. They share properties with metals and nonmetals. They are right in between them, so they share properties. Silicon is the most common one. That's the second most common element in the Earth's crust, actually, silicon, which you should have learned in environmental science or biology. Silicon is Si, that's number 14. So here you go, here's a better picture. Again, it's pointing out hydrogen here. Hydrogen, that's the only non-metal on the metal side. We have metals over here. We have non-metals here. And then metalloids, again, they're touching this red line. So like silicon, for example, is here. Notice it's touching the red. Okay, I said this before with groups, but elements in the same group have similar chemical properties. Family, again, we don't call it that often, but if that helps you think of it, they're related. Families are related. There are specific names for the groups. We won't use all of them. Some will use more than others, but we'll go through them here. Group 1, pretty common to call them the alkali metals. The alkali metals. Again, do not include hydrogen. Hydrogen's there, but it doesn't really fit in with the family. It's a non-metal. Group 1 is the most reactive, are the most reactive metals on the periodic table, and we'll see that's because of their valence shell, but that's for later in the year. They're rarely found by themselves because they are so explosive and reactive in water. So sodium, for example, Na, you won't really find sodium in nature, because if it would ever rain, that would be bad. We know something sodium chloride, right? Table salt. But notice it's not alone, it's with chlorine there. This stuff down here, I'm not really worried about right now. That's just more information. We'll get to ions and stuff later on in the year. We already said about conducting electricity, and they're shiny. Group 2, again, a pretty common name we'll use, the alkaline earth metals. This is group 2. This starts with beryllium. Pretty reactive, not as reactive as group 1. Still metals, so they still share the properties. Again, this second bullet point here, I'm not worried about right now. We'll get to that later in the year. But group 2, just called the alkaline earth metals. Group 3 to 12, this is kind of like the indent in the periodic table. We just call them collectively, groups 3 to 12, as transition metals, or the transition elements. Again, they are metals. They are weirder than the other groups, which is why we separate them. We kind of indent it down there. Their charges, which we'll see later, don't really follow a rule necessarily like the other groups. But they are metals. Most are solid at room temp, except mercury. That's a liquid at room temperature. The only other element that is a liquid at room temperature is bromine. So mercury and bromine. Group 13, the boron family. It's just called the boron family because the first element in the group is boron. So I won't refer to it as the boron family. It's group 13. Again, not terribly worried about much there. Just going through the groups here. Group 14, same idea. It's the carbon family because it starts with carbon. Not terribly worried about that. Same idea with group 15, starts with nitrogen, so it's called the nitrogen family. 16, likewise, we also do give it another name, the chalcogens. You might hear that a couple times, but not crucial for us. 17, pretty important, the halogens. This starts with fluorine. Most reactive nonmetals. So interesting that the most reactive metals are group 1. Most reactive nonmetals are group 17. Maybe you thought it would be group 18 on the ends. We'll see group 18 doesn't like to react. Hopefully you can see something here. Sodium and chlorine. Really reactive sodium metal, really reactive chlorine nonmetal. They like to bond. That's how we get our table salt. So again, group 17, the halogens. Group 18, very important, called the noble gases. You want to know that. They are inert. Inert means they do not react. They're non-reactive. Why? They have a full, what's called a valence shell. They have enough electrons in their outer shell that they do not want to give any away, and they do not want to get any. They are happy with their shell. So they don't react. They don't form ions, and they're called the noble gases, so they are all gases. This will start with helium. So group 18, you want to know they're called the noble gases, and they are inert or non-reactive. And lastly here, the bottom two periods that kind of stand out are called the rare earth metals. Some are radioactive. They do conduct electricity because they are metals. They're called the lanthanides and the actinides. The arrows are a little messed up here. Lanthanides are the top period, actinides are the bottom. Remember though, these two periods are not separate from the periodic table. We just draw them separated. So the lanthanides are actually period 6, and the actinides are actually period 7. So they actually get inserted up here.